Good morning, one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV62 for 6 semester students, Module 1 and Lecture Series 7. Today we are discussing about stabilization of borehole and sampling techniques. What is meant by stabilization of borehole? So, whenever we are making a borehole, drilling a hole into the soil for collection of soil sample, the sides of the wall cannot possible to stay on its equilibrium position because there is a pressure which is acting on the wall from the surrounding, and there is a hole at the center which leads to the caving in. Caving in means collapse of the soil. ಮಣ್ಣು ಕುಸಿಯುವುದು, ಹಳ್ಳದಲ್ಲಿ ಮಣ್ಣು ಕುಸಿಯುವುದನ್ನ ಕೇವಿಂಗ್ ಇನ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ if you don't avoid this caving in of the soil, further progressing of the borehole cannot possible. In order to progress the borehole beyond the collapsible depth, so we have to make a borehole stable. The process of or the technique of making a borehole stable beyond the significant depth or the critical depth of exploration is called as stabilization of borehole. Stabilization of borehole will be done in various methods. One is stabilization with water and stabilization with the drilling mud. In foreign countries, they are doing stabilization by freezing technique, stabilization by throwing technique, but the freezing and throwing technique are very expensive techniques. Therefore, it is not used in Indian environmental condition and it is not required also. So, coming to the first one, stabilization with water, what we have to do when we are making a borehole? So, pump the water into the borehole so that all around the borehole, the earth pressure is acting towards the hole, whereas the water pressure is acting in the opposite direction. So, earth pressure is Ka gamma H square, whereas water pressure is gamma W half into gamma W into H square. So, the half into Ka gamma W H square will, if it nullifies with the half into gamma W H square, then the borehole is stable. Second thing is the self-weight of the water, density of water is 1. The self-weight of the water is pushing the water pushing the soil in downward direction. Therefore, the heaving of the soil will be prevented. Thereby, stabilization of borehole is achieved. So, this is by using water circulation method. So, second one is by drilling mud. Generally, in case of wash boring beyond casing length, so what we are doing is drilling mud will be used. What is meant by drilling mud? A highly plastic clayey soil is called as a drilling mud. Generally, bentonite slurry will be prepared and that slurry will be circulated into the borehole. As the surface tension of the bentonite slurry is very high, wherever cracks develops in the open excavation of the borehole, this will bridges that crack and it acts as a gum type one, so that caving in of the soil will be prevented. That is by using drilling mud. Have you understood? Okay, fine. Next is sample and sampling technique. What is meant by a sampling and what is meant by a soil sampling? Sampling or soil sampling is one and the same. A soil sampling is the process of obtaining the samples of the soil from the desired depth at the desired location in a natural soil deposit with a view of assessing the engineering properties of the soil for ensuring the proper design of foundation. So, if you want to make index property or engineering property, we have to collect the soil sample, right? To collect the soil sample, some technique we have to use it, whether we have to collect it in a bag, whether we have to collect it in a tube, whether we have to collect it in some other method. So, some technique we have to adopt it. The technique of collecting the soil sample is called as sampling. Sampling means it is a process of collecting the soil sample is called as sampling. There are three types of samplings are used or samplers are used. One is undisturbed sample, another one is a disturbed sample, representative sample. Suppose if the structure of the soil before and after excavation should remain one and the same, then it is called as an undisturbed sample. If the structure of the sample is disturbed after excavation, then it is called a disturbed sample where moisture is also lost. Representative sample means even the structure of the sample is disturbed, but the moisture will be protected, then it is called as a representative sample. To collect that samples, we are using some samplers. Samplers means those are all some tubes. One is undisturbed sampler tube, that is a thin wall sampler, or we can go for chunk sampling technique. And another one is the disturbed sampler tube, it's called a thick wall sampler. Another one is a stationary piston sampler is used for representative samples. So the figure indicates the disturbed soil sample. Why it is called disturbed soil sample? Because it depends on the sampler tube thickness. What is meant by sampler tube thickness? Sampler tube thickness means the thickness between the outer wall to the inner wall will decide whether it is a thick wall sampler or thin wall sampler. If you substitute that outer diameter and inner diameter of the tube in the formula is area ratio is equal to outer diameter square minus inner diameter square divided by inner diameter square into 100 is called area ratio. Let us say in this case the outer diameter is D2, inner diameter is D1, then D2 square minus D1 square divided by D1 square into 100, if you do it, you will get area ratio. If that area ratio is greater than 10%, then we can say that that sampler is a thick wall sampler. From that sampler, if your soil is collected, then it is a disturbed sample, because to penetrate that thickness of the wall into the soil, surrounding soil structure will be totally disturbed, therefore it is a disturbed sample. Coming to the next one, thin wall sampler. What is meant by thin wall sampler? As I said earlier, area ratio calculation. If that area ratio, if you calculated, that is D2 square minus D1 square divided by D1 square into 100, if you calculate it, if it is less than 10%, and by using such a thin tube samplers in the soil, if you collect it, then that is called as a thin wall sampler. So such a type of sampler, the structure is not disturbed, so therefore it is an undisturbed soil sample we can collect it. Another one is a chunk sampler. Chunk sampler means, suppose I want to collect some sample, so in a area, so surrounding area you make a trench, isolate that soil from the surrounding area. That is step number 1. Take a wooden box whose size is greater than the isolated soil sample size. Place that wooden box, and surrounding to that wooden box fill the sawdust, so that there should not be any gap between the sample and the box. Afterwards, top also put some sawdust and waxing should be done. Top, you close the top of that box by using a spatula, upside down it, and excess soil will cut the excess soil, put the sawdust, wax, and close the lid, and with minimum disturbance you take to the laboratory. Then you remove this box and course you extract from the core from this sample, and that sample is called as a chunk sample. Chunk means it is a mass chunk sample. That sample is also have minimum disturbance, therefore we can expect undisturbed sample by using this technique. Next is representative soil sample or stationary piston sample. Suppose you want to collect the soil sample, so but structure has, if it disturbs, moisture has to be maintained, means when you are using this one. So you can see here this is a sampler tube, and central there is a extension rod, and here there is a piston will be there. So thin wall tube will be there, piston will be there, a turning rod and thin wall sampler end, and first you press this tube into the ground. Afterwards, lift this tube vertically upward direction. A vacuum creates here which pushes the soil in the upward direction. If a wall used is a thin wall, then you can get a thin wall UDS sample. If the wall used is a thick wall, you can get a disturbed sample. So once it is moved, the air will not possible to enter from upward to downward direction because of the locking cone and spring arrangement will be there, so that pushing of soil will not be there. So minimum disturbance can be expected using stationary piston sampling. Coming to the MCQ questions about this particular topic. So first question is, the most commonly used way of stabilization of soil is stabilization with water, stabilization with drilling mud. So those are all the two most commonly method used, therefore answer is true. Stabilization by freezing is also used in specific cases. Yes, it is true. Stabilization by grouting is also used in always. No, it is not correct. It is false. Answer is B. Soil sampling is the process of obtaining samples of the soil from a desired depth at a desired location in a natural soil deposit. Answer, that is, the statement is correct. Therefore, option is A, true. Drives used for process of sampling is known as soil sampler. Yes, it is true. UDS stands for undisturbed soil sample. Yes, answer is true. It is A. RS stands for reserved sample. No, RS stands for representative sample. Therefore, statement is wrong. Our option is B, which is false. DS stands for direct soil sample. So option is A, true. Disturbed direct sample. The DS stands for direct sample. It is not direct sample. It is a disturbed sample. So option is B. It is false. Next is, the disturbed sample is a thick wall sampler. Yes, it is true. Disturbed sample, a thin wall sampler. No, it is false. These are the list of references we are used for preparing this module. On this session, I take this opportunity to thank Department of Collegiate and Technical Education officers and students for giving me an opportunity to deliver this lecture. Thank you, students. All team regarding will shut down.